All right, this video is going to cover about proving that you have a parallelogram. Technically, it would be on a coordinate grid. We're not going to have any pictures, but it's going to be using the distance formula and the slope formula. Okay, and these we learned earlier on in the year. So we're going to first start off with method one. Method one, using the distance formula, is going to prove that your opposite sides are congruent, because that is one of the properties we talked about with parallelograms, that opposite sides are congruent. So in order to do that, you have to figure out the distance between point A and point B. How long is that side? So to remember what this distance formula is, it's a very, very long one. Okay, I'm going to leave some room, so we have to put a radical sign. This is going to be x2 minus x1 in parentheses squared plus y2 minus y1 squared. And over the entire thing, we have this radical sign. Please pause if you need to get caught up, because I'm going to try to make this as short as possible. Another property that we talked about parallelograms is that it comes from the name, the opposite sides are parallel. Well, in order to do that, we need to compare the slopes. If the slopes are the same, we talked about this, if the slopes are congruent, then the lines are parallel. If they are not congruent, then they're either not parallel, or they're just intersecting, or they're perpendicular. So we need to look for using the slope formula in order to see if they come out to equal the same exact thing. Exact same rise over run. So your slope formula was y2 minus y1 over x2 minus x1. It's the change in y over the change in x. So this first section here, we're going to try method one. We're going to use that distance formula. This is the longest one. Okay. And what we're going to do is we're going to assume that A, B, C, D, these are in order. So we're going to go ahead and draw out quadrilateral A, B, C, D, because I'm going to do some color coding. If you want to get some colors, might be a good idea so that we can see what's going on here. So the length of AB. So here, let's first find the length of AB. We'll define AB. We need points A, which is -7, 4. And we need point B, which is 1, 2. So with the distance formula, and well, even with the midpoint formula, I've always taught my students to label your x's and your y's. So here we're going to have x1, y1, because it's the first coordinate written, x2, y2. So that we can follow our formula right here, and we can plug everything in where it belongs. We don't. It's less of a chance of making a mistake. So right here for AB, we're going to go ahead, and I'm going to put the radical sign here at the very, very end. Actually, let's do this. Move it over a little bit and write a little smaller. We're going to have x2, which is 1, minus x1, -7. Make sure you put that negative there. Close parentheses squared, plus, open up parentheses, we're going to have y2, 2, minus y1, 4, all squared. Then we want to make sure we do not forget that radical sign. It's very, very important. If we solve this step by step, which I encourage you at least do some of the steps by themselves, step by step, because you make one wrong move and put one thing wrong into the calculator here, you have the wrong answer. So here I'm going to take a look at taking 1 minus -7. So 1, and I'm going to keep this in parentheses, and you'll see why if you don't remember. 1 minus -7 is going to give you a positive 8 squared, plus 2 minus 4 is going to be a -2 squared. The important reason of putting this in parentheses, if you put -2 squared in the calculator, and a lot of calculators, without the parentheses, it's going to square the 2 first. It's going to follow the order of operations. It's going to multiply first, or sorry, it's going to do the exponent first and then add on that negative. Please make sure these negative numbers squaring are in parentheses, or you'll get the wrong answer. You're going to get a negative, and you can't have a negative when you square a number. So now going to the next step, 8 squared is going to be 64, plus -2 squared is a positive 4. Any negative number squared is a positive. It's negative times a negative. So then we end up with the square root of 68. Generally at this point, I would tell you to simplify it. We already done a lot of work, okay? So let's just go ahead and move forward. Now we're going to go to the length of BC. BC is not an opposite side, so I'm doing this in a different color here, okay? So for point B, we already have right here is 1, 2. And then C, as we see up here, is 9, -8. So labeling with our x1, y1, x2, y2. we're going to go ahead and plug in. I'll just go ahead and draw a really long one here. So I want, and the formula's way at the top, but we're going to have x2, 9, minus x1, 1, squared, plus y2, negative 8, minus y1, 2, squared. This then, once we do the subtraction on the inside, we're going to wind up with, I guess I'll leave it in there, 8 squared, plus negative 8 minus 2 is going to give us a negative 10 squared. Then we take the we square them. 8 squared is 64, negative 10 squared is 100. Add them together, we get the square root of 164. Now these don't match, but again, okay, these are not opposite sides. Now we're going to take a look at side CD. So this one's going to be opposite. That's why I have the colors. So CD should come out to the square root of 68 in order for us to start saying, yeah, it might be a parallelogram. So here we have C is at 9, negative 8, and D here is at 1, negative 6. All right, so let's go ahead and start plugging in. We have, let's label our x1, y1, x2, y2. We have x2, 1, minus x1, 9, squared, plus y2, negative 6, minus y1, negative 8. Make sure we have that minus negative there. Okay, very, very important to have that minus negative. So now we're going to go through and solve the subtraction problems here. 1 minus 9 is going to give you a negative 8 squared, plus, now we have a negative 6 minus a negative 8. That's going to turn to a negative 6 plus 8. We're going to go into the positives here. We're going to have a positive 2 squared. When we square these, again, we got that 8 squared again as a negative, but negative 8 squared is 64. And then our 2 squared is 4, giving us the square root of 68. So far we have one pair of parallel sides, congruent sides. All right. Let's check out side AD to make sure, because if this is not congruent to BC, we do not have a parallelogram. Even one off makes it not parallel, or makes it not a parallelogram. So here's side A, which was the negative 7, 4, and D, 1, negative 6. All right, set up, parentheses, we're going to leave my x's and y's again, x1, y1, x2, y2. So here we have x1, I'll move it up for you, x2 is 1, minus x1, negative 7, again, make sure you have that minus negative 7, plus y2, negative 6, minus y1, 4. All right, let's solve what's in the parentheses, order of operations. 1 minus a negative 7 is going to end up being a positive 8 squared, plus negative 6 minus 4 is going to give me a negative 10 squared. Go through and square them. 8 squared, so that's 64. We've had a lot of that. Plus negative 10 squared is 100. We add them, and we're going to get the square root of 164. So our opposite sides are parallel. So we do have a parallelogram. Okay? I know it's a lot of work, right? Please pause, catch up, whatever you need to do. On number 2, I'm going to give you kind of a spoiler alert. We're only going to do 2 of these. Okay, and you'll see why. When number 1 is a lot of work, right? Here we've got a parallelogram W, X, Y, Z. I'm going to take 2 sides that are supposed to be congruent. So let's say XY right here and WZ right here. So with XY, using my formula, okay, I'm going to kind of skip, but here, XY, we've got, well, I'll just erase this. Here's X1, Y1, X2, Y2. we're going to have parentheses x2, 4 minus x1, 8 squared plus y2, 4 minus y1, negative 2 squared. Okay, take this step by step. 4 minus 8 is going to give me a negative 4 squared plus 4 minus a negative 2 is going to give me 6 squared. Let's get these squared and then add them. Negative 4 squared, positive 16, plus 6 squared, a 36. When we add them, we're going to come up with the square root of 52. So now let's go check out. When we erase these, we're going to look at, well, I guess it doesn't matter. We're going to look at WZ, making sure everything's still on the screen. So W, I'm going to put X1, Y1. We can erase these so we don't get confused. X2, Y2. All right, so the same thing we've been doing. X2, 9, minus X1, 3, squared, plus Y2, negative 3, minus Y1, 5, squared. Again, pause it, please. Okay, do the math on your own. You can do it. 9 minus 3 is going to give you 6, positive 6 squared, plus we're going to take the negative 3 minus 5. We're going to end up with a negative 8 squared. Go ahead and square 6 to get 36. Square negative 8 to get a positive 64. We get this. It's going to be the square root of 100, which is a perfect square. So if you notice, these opposite sides, that's why I'm not going through all 4 of them, okay? I knew which 2 were not going to be congruent, and so therefore, we're going to write on here, not congruent, so not a parallelogram. Pause it and get that finished, okay? They're not congruent. We're going to go ahead and take a look at method 2 now. Method 2, in my opinion, goes a little bit quicker because we're using the slope formulas. There really aren't a whole lot of steps here, okay? So method 2, slope formula, and I'm going to go ahead and write the slope formula over here, up here real quick, since it's on the other side. Y2 minus Y1 over X2 minus X1. So, parallelogram, if it's a parallelogram, we have A, B, C, D. So let's check out our first pair. Let's look at AB right here. So A being negative 7, 4. Starting off exactly the same we did earlier, writing down our coordinates because we have X and Y as 1s and 2s. We'll go ahead and call this X1, Y1, X2, Y2. So with our slope, we want to make sure that the Y's are on top. We have Y2, 2, minus Y1, 4, over X2, 1, minus X1, negative 7. When we solve the top, we're going to wind up with a negative 2. When we solve the bottom, we're going to wind up with a positive 8. When we simplify this, this is going to come out to a negative 1/4. Okay, so there's the slope. Let's take a look at BC right here. So we have point B at 1, 2, right? And then we have point C at 9, negative 8. All right, let's plug in for our formula here. Again, keep forgetting. Just getting ahead of myself. I'm trying to make this as quick as possible. We have Y2, negative 8, minus Y1, 2. On the bottom, we have X2, 9, minus X1, 1. When we take this all out, that negative 8 minus 2 is going to wind up as a negative 10 over 9 minus 1 is an 8. We simplify this down, and we get negative 5 over 4. Now, on the distance formula, I know I told you guys don't worry about simplifying these radicals because they're all going to come out not simplified at first. Here, you need to make sure that you are simplifying these fractions because I don't want to see like a negative 5 over 4 and then a negative 10 over 8 and be like, oh, they're not similar, or they're not congruent, which they would be, okay? So always simplify these fractions. All right, so CD right here, opposite. When we come down to the slope, we should have negative 1/4. If we don't, then they're not parallel. Or they're not parallel. So here C, 9, negative 8. Point D is at 1, negative 6. X1, Y1, X2, Y2. All right, let's plug in. Y2, negative 6, minus Y1, negative 8. Making sure, again, we have that minus negative. They're not going to replace it, okay? And the denominator, we have X2, 1, minus X1, 9. So a negative 6 minus a negative 8 is going to give us a negative 2. Type it in that calculator if you don't trust me, okay? But trust me. And then we've got our 1 minus the negative, or sorry, 1 minus the 9. Oh, wait, sorry guys, mistake here. Maybe you shouldn't have trusted me. Negative 6 minus a negative 8 is going to give you a positive 2, because it's negative 6 plus 8. Then you have your 1 minus 9 is going to give you a negative 8. We simplify that. It comes down to the negative 1/4. So far, segment AB and segment CD are parallel. They have the same slope. We need to make sure we continue on, and let's check with segment AD and see if it comes out to that negative 5/4. So here looking at point A at negative 7, 4, and point D at 1, negative 6. Over X1, Y1, X2, Y2. So let's plug in. Y2, negative 6, minus Y1, 4. In the denominator, we have X2, 1, minus X1, negative 7. In the numerator, negative 6 minus 4 is going to give you a negative 10. And the denominator, 1 minus negative 7, gives you a positive 8, simplifying down to negative 5/4. So we have 2 pairs of parallel sides. So since if only one was parallel, it wouldn't work. Okay, so there we go. Probably figure out what's going to happen on this next one. We are going to look at X, Y, and WZ again. Let's go ahead and draw this fellow first. Okay, we got W, X, Y, and Z. Let's take a look at XY. There's not a really pretty Y there. So looking at XY, here we've got X1, Y1, X2, Y2. Using our slope formula, we have X2, 4, minus Y2, 4 minus Y1, negative 2. Make sure minus a negative. Now we have X2 in the denominator, 4 minus X1, 8. And we plug this in the calculator. You just jump straight to the calculator, plug everything in the numerator and denominator. We're going to come up with a negative 3 over 2. Now when we check out the other side, WZ, there's our X's and our Y's. We're going to have Y2, negative 3, minus Y1, 5, X2, 9, minus X1, 3. We plug this all into the calculator. We're going to get a negative 4/3. The opposite sides are not parallel because the slopes are not the same. Okay, so not parallel slopes. So not a parallelogram. And the last part that we have down here, did either method change your outcome? Which method did you prefer? Because now that you know, number 1 and 2 on the distance formula was the exact same as number 1 and 2 on the slope formula. So we should not have had any outcomes changed, and then it just asks which method do you prefer, because you can use either one. Please ask your teacher if you have any questions, or you can search on YouTube for other proving parallelograms on a coordinate plane videos.